All right, let's dive right in. We're going to journey through the cosmos to tackle one of the biggest questions out there. Are we a cosmic miracle? We're going to look at the chaos, the sheer violence, and honestly, the incredible luck that made our world, our home, even possible. So let's get started.
When we think about aliens, we kind of picture them on a planet a lot like ours, right? Evolving in some nice, calm, stable corner of the galaxy. But what if that's totally wrong? What if our quiet little solar system is the weird one, the exception? What if for most life out there, just existing is a much, much wilder ride?
And calling it a wild ride is, frankly, a huge understatement. The universe isn't just this vast, quiet, empty space we see at night. No way. It's a place of absolutely immense power, constant, churning change, and sometimes just unimaginable destruction.
Okay, so you want to know how wild it can get? Let's start with one of the most extreme things astronomers have ever seen. I'm talking about cosmic projectiles, but these aren't rocks. We're talking about entire stars being flung across the void.
Think about that number for a second. 620 miles per second. That is so fast, you could cross the entire United States, coast to coast, in less than 5 seconds. Now imagine something with the mass of our sun moving that fast, faster than a rifle bullet. It's a mind-bending but very real part of our universe.
So what in the universe has the power to do something like that? Well, the culprit is right at the heart of our own galaxy. It's the supermassive black hole Sagittarius A star. Here's how it works. You have a binary star system, right? Two stars orbiting each other. If they wander just a little too close to that black hole, its gravity grabs them. It's like a cosmic slingshot. It snags one star, pulling it into a new orbit, and then just violently yeets the other one completely out of the galaxy. It's like a gravitational hammer throw, but on a scale that's almost impossible to imagine.
Now just picture this. What if there was a planet orbiting one of those stars that got shot out? Any life on that world would have the most incredible view imaginable. They'd get to watch our entire galaxy, the Milky Way, shrink behind them into this beautiful, glittering swirl. It's kind of poetic. But what if a planet gets flung out on its own, without its star? Well, that's a much darker story. Its fate is to freeze solid and just wander the empty void between galaxies forever. Okay, so it's pretty clear the universe is a seriously dangerous place, which just makes you stop and think, right? How did the basic ingredients for life, us, even get started in the first place? Well, the answer, believe it or not, starts with fire. The very atoms that make up your body, my body, this whole planet, they were all forged inside the nuclear furnaces of ancient stars. And when those stars reached the end of their lives and exploded as massive supernovas, they blasted those precious, life-giving elements out across the cosmos. It's amazing, really. We are literally made of stardust. The death of stars was the beginning of us. So, what are these building blocks exactly? Well, carbon is the absolute superstar here. It's like the architectural backbone for all life as we know it. But it's not a solo act. You also need things like amino acids for proteins, nucleic acids for DNA, ribose sugar, phosphorus, the whole shebang. And the crazy part? All these fundamental ingredients you need to build a living cell, they're just floating out there in the vast emptiness of space. Okay, so the ingredients are out there, but how did they get here, to Earth? Well, it looks like we had a cosmic delivery service. I'm serious. Scientists have found really crucial stuff, like ribose and phosphorus, on actual meteorites and comets that have landed on Earth. This strongly suggests that a very young Earth was basically seeded from space, bombarded by these cosmic packages carrying all the stuff needed to kickstart life. So we've got our ingredients delivered fresh from the cosmos. But, just having flour and sugar doesn't mean you have a cake. You need the right kitchen, the right oven. You need a safe harbor, a stable place for all those ingredients to mix together and, poof, spark into life. And that brings us to the incredible story of how Earth became a cosmic fortress. And our first line of defense? It was actually born from a totally catastrophic event. Billions of years ago, a planet about the size of Mars, scientists call it Theia, slammed right into a young Earth. The debris from that massive collision eventually came together to form our moon. And honestly, this was unbelievably lucky for us. The moon keeps our planet from wobbling all over the place, and its gravity creates the tides, which constantly churn the early oceans, mixing up that primordial soup of chemicals and helping to create the very first life. But what's the single most important defense we have? The one thing that made all the difference? To answer that, we just have to look next door, at Mars.
See, both Earth and Mars started out pretty similar, warm, wet, with potential. But today, Mars is a frozen, dead desert. So what happened? The difference is deep underground. Earth has this hot, molten, churning core, and that generates a powerful magnetic shield around our planet. Mars, well, its core cooled off and died. And that, right there, was game over for Mars. Without that protective magnetic shield, the sun's solar wind, this constant stream of radiation, just blasted Mars for millions of years. It stripped its atmosphere right off, and once the atmosphere was gone, there was no pressure to hold the water down, so the oceans literally just boiled away into space. All that's left is the sterile red wasteland we see today. That shield, that invisible shield, is what's keeping us alive. But wait, there's more. We have one more layer to our fortress, a cosmic bodyguard, if you will. One so massive that its very presence shapes the fate of our entire solar system. And that bodyguard is Jupiter. Its gravity is just immense. It acts like a giant bouncer for the inner solar system, deflecting or completely swallowing up countless comets and asteroids that would otherwise be headed straight for us. I mean, scientists estimate that without Jupiter, Earth would be hit by major asteroids about 1,000 times more often. 1,000 times. We basically owe our relatively peaceful existence to that giant gassy planet hanging out way out there. So, let's recap. We've got the ingredients for life. We've got this incredible cosmic fortress protecting us. We're here, we exist. But when you think about the billions, maybe trillions of other planets out there, it all leads to this really chilling question: where is everybody else? This is what's known as the Fermi paradox. And one of the most popular and kind of scary answers is something called the Great Filter. The theory goes like this. There's some step in the long process of evolving from a single cell into a civilization that can travel the stars that is just so incredibly difficult, so improbable that almost nobody makes it through. It's a filter that wipes nearly everyone out. So what could this filter be? It could be something external, right? Like a massive asteroid hit or a random gamma ray burst from a dying star that just happens to sterilize an entire chunk of the galaxy. That's bad enough. But maybe the filter isn't out there at all. Maybe it's in here. What if any species that gets smart enough to develop advanced technology inevitably uses it to destroy itself? A filter that we build with our own hands. That's a pretty grim thought, I know, but there is another possibility, a more hopeful one. What if the universe isn't silent? What if we're just looking at all the wrong places or listening for the wrong kinds of signals? For example, we tend to look for life around stars like our sun. But most stars in the galaxy aren't like our sun at all. They're smaller, cooler stars called red dwarfs. They are, by far, the most common type of star. And here's the kicker. They live for trillions of years. Not billions with a B, trillions with a T. That is an almost incomprehensibly long time. Plenty of time for life to get started, to evolve, and maybe become something we can't even imagine. So you take all of this, the sheer chaos of the universe, the incredible luck that led to us, and this great cosmic silence, and it really forces you to take a step back, to just think about what it all means, to be here on this planet right now. Because when you get right down to it, searching for others is really just another way of searching for ourselves. Imagine if we found the ruins of an alien civilization that had died out. It wouldn't just be an amazing scientific discovery. It would be a warning. It would be like staring into a mirror and seeing a possible future, a fate that we absolutely have to figure out how to avoid. And that leaves us right back where we started, with the ultimate question. Are we just a 1 in a trillion fluke? A tiny, brief flicker of light in a vast, empty cosmos? Or are we just the first ones to make it this far? And if we are, what does that mean? Does it mean we have a responsibility to be smart, to survive, and maybe, just maybe, one day be the ones to finally break that great cosmic silence? The answer is still out there, waiting for us.